Yeah.
Remember last year?
It's on video. Tell me.
Remember last year?
Yes.
On Halloween, you said if we wear a costume, we get extra.
Oh, we're gonna. What, you want that on video? So that if you wear it on Halloween, is Halloween even on an A day? I don't know. It is true. On last time, because you guys were all so bad at math, I had to make ways to give you guys credit. All right. If you wear your costume at Halloween, unless it's like something against you or whatever, that on the quiz day that day, I will do something nice with your quiz. It's on video, right? What else do you need, right? But if all you're counting on are silly extra credit stuff, right, rather than earning something. Hey, this is Mr. G Math coming at you live, right? Room 7202. We are now doing lesson 5.5, which is understanding integration at the next level. So, the lesson, you're going to listen, right? The lesson before was just the basic power rule, but in the other direction. What was the basic power rule, but in the other direction? You add 1 to the exponent, and then you divide. The lesson today is going to really focus on the chain rule and going in the opposite direction. And sometimes you have to do algebra substitution to integrate. You can go on all you want, but everything's learned by practicing. And you never learn here in the first 15 minutes. You always learn when you go home and practice and watch and practice and watch and practice. That's where you learn. Right now I'm just setting it up. So you have to commit yourself that you have to do math outside the classroom. So look at the general power rule. The general power rule means if there's a chain involved, right? And so you can see if you're integrating u to the n, u, that means the derivative of u, dx, that's the chain. So if this was like the parentheses, the derivative of the base is the chain at the end, right? So this is the chain. What would the derivative be? Well, you would add 1 to the exponent, so it's n plus 1, divide, and notice that if the chain is included, you don't have to then worry about the u prime because it's already embedded. So we're going to look at questions 1 and 2, and then we're going to practice. You're not going to learn in 15 minutes. I can only set it up, and then when we come in at lunch or the next time in the morning, right, that's when we're going to learn, is when you decide you're going to fight through the material. So look at example number 1. It asks you to do what? What does that mean? Go for it. Goodness, you know your life changes massively when you know that you have to earn what you got, right? Whatever it is. You want a house, you want a car, you want whatever you want. Then when you decide you're going to flip the switch and everything's going to be earned, your calculus grade and everything else, everything switches, right? And things become a lot different than just being given to you. How do you take the derivative for number 1? What rule do you have to use? Chain. So that 4 goes in front, and then subtract 1, and it becomes 3. Take the derivative of the base. That's the chain, and it's 5. Could you also write this as 20? 1 plus 5x cubed. Do I need to include candy here?
No.
Good, because you're taking the derivative, right? Now integrate. It's more complicated, right, to integrate? This is what I want you to notice. Do you see a base to the exponent? No. Do you see a base? Whenever you see an exponent, there has to be a base with it. Yes? Yeah. So you're not going to do this every time. But let base be u. So in this case, base would be 1 plus 5x. If I took the derivative of the base, what would that be? 5. Do you see the derivative is already included? That means the hook is ready to take the derivative. So you look, is the hook present? If it's not present, we actually have to do a little bit of maybe algebra to make it look ready, and then we can integrate easily. Because the act of integrating is still adding 1 to the exponent and dividing. So if I add 1 to 3, it is now. And then when you divide, it is, I need x, and then include the constant. How can you always double check to make sure it's equivalent? Derivative, 4 times the 1/4, what happens there? If I take the 4 and multiply in front, the 4 and the 4s do what? And then subtract 1 from the exponent, and now it's down to 3. What's the derivative of the chain? And you can see that left side equals right side. Again, I'm setting up the learning, right, that you're going to have to practice. This is another calculus rule, a technique. We're going to eventually get to the point that's more fun where you apply it, right? Word problems. But if we don't have the skill, then we can't do anything. If you don't know how to hammer a nail, you're not building a house, right? That kind of thing. Let's look at number 3. So it says, note, and they use the word hook. It says, you hooked on for the derivative of the power function, example 1. So you had to unhook the derivative inside for example 2. So you are going to listen to the best of your ability. For number 3, do you see a base and the exponent?
Yes.
Good. What's the derivative of the base before I integrate? 3. So what I need it to look like is this in order to integrate. Because the hook must be present in order to do the general power rule. This is the anti-chain rule. If you don't see the hook in front, you can't do the anti-chain rule. So did I see the 3 in front? No. So what did I put? The 3 in front. Are these two equivalent? No. So the question is, do you have the ability to make the two equivalent? And I hope the answer is yes. What needs to be included in front so that they are equivalent? And the question is 1/3 times 3, is that 1?
Yes.
So what I had to do is change the look of it to include the hook. But when I did that, I had to undo it in front so it stayed equivalent. So I needed the 3 in front because the derivative of the base is 3. It is now not the same. But now what can I do to make them the same because it's just a constant? What needed to be in front? If I take 1/3 and multiply it, will it be equivalent? Yes. So the 1/3 will stay in front of the answer. Then what do I do? What do I do with the exponent? Add 1. What would that number be? Divide, or the same would be 1/11, or divide by 11. And then don't forget the candy. Could you also write this as 3x minus 1 to the 11? What's 3 times 11? I'm only writing this, so when you see multiple choice, could you see that as an answer for multiple choice? That was the ghost that brought that down. So, I didn't touch the paper. So 3 times 11. Can you see where I got 33?
Yeah.
Do you know you're not going to learn it all right now? But we're setting it up, believing, we're fighting and not like running away from it. Okay, number 4. Here we go. Now, do you see that there are 2 factors here being multiplied? I want you to focus on the factor that has the bigger power term. Which factor has the bigger power term? The first factor or the second factor? That's right, t cubed, right? I want you to take the derivative of the second factor. What's in your head? What's the derivative of t cubed? What's the derivative of t squared? What the hey did you just see? That the derivative of one factor is actually right there present in front as a product of the second factor, right? Do you notice the derivative of the second matches exactly the front? That means you don't see an exponent on the second factor. But what exponent is there? 1. So how do I do the anti-power rule? What do I do for the integration? What do I do with 1? Add 1. And so add 1, the exponent is now 2. We can divide by 2 or 1/2 and then the candy. I know. Here it is. Now, what can you always do to make sure that you integrate it correctly? Take the derivative. What's 2 times the 1/2? What happens to the 2 and the 2? And then you subtract 1 from the exponent and it's now, subtract 1 from the exponent and it's now 1. And then what's the derivative of the chain, the base? 3t squared plus 2t. And you can see that it's equivalent, right? If you take the derivative or you integrate, right? They match. And we're fighting through this. Number 5. I want you to take a look at the base. Do you know there's a different way we can write this? So we're going to write it as 6x squared, parentheses, 4x cubed minus 5 to the negative 1/2. So it looks calculus-y. I want you to be able to see u and u prime. U is the base. U prime is the hook. Can you see u and u prime? U is the base. Look at it. What's the derivative of u prime? I'm going to write it down. 12x squared. Are these equivalent? No. What constant would make them the same? And if you can't see it, you can just divide the two constants together. Right? Like the original over what we need, right? 6 divided by 12 is what? Now, when I go 1/2 times 12, now is it equivalent? Oh, no, it stays. So I took the derivative to see if the hook in front matched correctly or if I had to do some changing. So I took the derivative of 4x cubed to see if it matches what was in front. And it didn't exactly, right? But if I put 1/2 in front, does it now match? Yes, so my answer is going to have what in front? 1/2. Perfect. Next, do you see the exponent negative 1/2? What do I do with that exponent? Add 1, and that's now what? Positive 1/2. Then what do I do with the new exponent? Divide by 1/2, which is the same as, and don't forget the candy. Is there another way you could write this if you wanted to? 1/2 times 2 means you're just left with 4x cubed minus 5 to the exponent 1/2. What could you do to see if it's equivalent? So what would happen if 1/2 was in front and then negative 1/2? I want you to know that when you take the derivative inside, you get 12x squared and the 1/2, which then together make the 6x squared. All right, one more like that, and there's plenty to practice for homework. You make the choice to practice the assignment or come in at lunch. 6. Do you know what u is? U is u cubed plus 1. Do you know what u is compared to u prime? U is the base. What is u? Y cubed plus 1. What's u prime? 3y squared. What's in front? Nothing. So I want you to know that you can manipulate a constant, but you cannot manipulate a variable. So in other words, I cannot write down, oh, I want 3y squared, right? That's what I want. So that means in front, I'm going to undo it so that it is equivalent. That's garbage. You can only manipulate a constant number, not if you need variables to manipulate in front of integration. Okay? So what do we need to do there? Is algebra before the calculus. Can you expand that in your head? Yes, you can. Here we go. What's y cubed squared? 3 times 2 is y to the 6th. I knew you could do that. What's y cubed plus 1 times 1? Y cubed times 1. Y cubed, double it. And it's 2y cubed. This is Pascal's triangle, its usefulness. Knowing how to expand a binomial, squared. And then 1 squared is 1. If you have time, go to your heart's content, right? Sometimes you don't have time on an AP exam. You got to practice some techniques that make things go faster. Could you now integrate this? Yes. Y to the 7th, divide. Y to the 4th, divide. That could be 1/2. Y, and then don't forget the candy. There's nothing on the AP exam that cares you and you reduce a fraction down. Your 3rd grade teacher cared. The AP calculus exam recognizes when numbers are beautiful in both ways, and they don't judge the beauty, as long as it's accurate. Okay? Turn the page. We ain't done. There are times, like the last question, remember when you tried to do the substitution, or you tried to see if the hook was there and it wasn't, and you can't manipulate a variable, that you actually have to do an actual substitution to be able to manipulate it algebraically to be able to take the integration. Here we go. There are 7 steps. Most often when this happens, you have a radicand, which is like a square root, cube root, something like with a root. So it says, let u be the part that's inside the square root. Then it says, solve for x in terms of u, differentiate the equation from step 2, find dx, substitute u in, don't forget to substitute dx in, integrate, then substitute back in. Fun. Here we go. You only learn by practicing, right? Number 7. Do you see the part? So first of all, why do I have to do this lengthy substitution technique? What is underneath the square root right now? What's the derivative of x minus 1? X minus 1. The derivative is 1. What's in front? X. I can't manipulate that variable in front. I can manipulate a constant, but not a variable. So I needed it to be 1 in front, but instead it's x, which means I need a different technique. So here we go. On the side, I'm going to say let u equal, what's underneath the square root sign? No biggie, right? You're following, you're working, you're earning something. Take the derivative. Or no, solve for x first. So if I wanted x by itself, what would x equal? Add 1 and it's u plus 1. Take the derivative, meaning the derivative of x becomes dx, and you don't see the 1. Take the derivative of u and it becomes du. And again, you don't see the 1. Sometimes when we take the derivative of u, it's already implied it's du by dx, but you can also take it separately and separate the dx and du. And the derivative of 1 is 0. So, come back to the question. Do you see an x in front? What does x equal? Done. Instead of x minus 1, what does x minus 1 equal? U. And instead of square root, I'm going to put it to the exponent 1/2. What does dx equal? Du. So now we're integrating with respect to u instead of x. Now we're going to do algebra, then calculus. How do I do algebra here? How do I distribute? What's the exponent law? Add. U to the 1/2 times u. If you add, what's 1 plus 1/2? So if I add them, it's 1.5 or 3 over 2. We're not doing any integration yet, right? We're doing algebra. And then what's u to the 1/2 times 1? Now, is it set up where I can integrate? So how do I integrate? Add 1. How do I do that with a fraction? What should I focus on? The denominator. So 1 is 2 over 2. So when you add, it becomes, divide becomes the reciprocal. Again, add 1, and it is 3 over 2. Divide, or the reciprocal is 2/3. And of course the candy. What's the next step? And the last step. What does u equal again? So go back and resubstitute in what u is, which is x minus 1, and now you've integrated. That's called integrating by substitution. Sometimes they just call it u substitution when you look at a calculus book. I'm listening.
So how do you, once again, how you said we couldn't integrate, or we couldn't use the hook because we could...
The derivative of x minus 1 is 1, and what I have in front is x. I can manipulate it if the variables match, and then if the constants are off, I can manipulate the constants. But I can't manipulate variables. So if the variables don't match with the correct exponent, then I need another technique to integrate it, just practicing. This is not what you want to do unless you have to do, right? So sometimes you have to. Number 8, our last one. Yay. We're fighting, not fleeing, right? Look at the denominator. What's underneath the square root sign in the denominator? The hook, the derivative of 2x plus 3 should be just what? 2. What's in the numerator? 2x, right? That x is the fly in the ointment. Silly x. If it said just a constant, like the number 6 on top, I can manipulate a constant and not have to do the substitution. But because it doesn't match that way, I have to set up what u equals. What's underneath the square root sign? 2x plus 3. What does x equal? No. What does x equal? So you subtract, so it's u subtract 3 all over 2. It might be helpful to separate it. So that's really 1/2 u, right? Because you need to take the derivative. So what's the derivative of x is dx. What's the derivative of 1/2 u would be 1/2 du. And the derivative of negative 3 over 2? 0. Now we're ready to go back into the question. Here we go. So where I see 2x minus 1, what should I put in its place? What does x equal? So that would be 1/2 u minus 3 over 2. And then minus 1. So instead of 2x, subtract 1. Where there's an x, you put in what x equals. Correct? Instead of dividing, what I'm going to do is I'm going to multiply. So instead of the denominator being the square root, we know what 2x plus 3 is. It is what letter? U. So I'm going to go times u to the negative 1/2. And then dx is 1/2 du. We got some algebra ahead. And that's an integration sign in front. So dx becomes 1/2 du. If you want, some of this we can bring in front. So do you see the 1/2 du? That 1/2 can be brought in front of the whole problem. We need to do some algebra before I bring any other number in front. So can you distribute the 2? What's 2 times 1/2? So it's 1u. What's 2 times negative 3 over 2? What happens to the 2's? And you're left with, and then what do we still have? Subtract 1. I'm going to put that around brackets, because then beside it is still u to the negative 1/2. Keep going. What is u subtract 3 subtract 1? That's u subtract 4, and then beside it is u to the negative 1/2. Distribute. U to the negative 1/2 times u. Add the exponents. What do you get? Good. Minus 4u to the negative 1/2. Now we're ready to integrate. So what's the integration rule we're going to use? What do I do with the exponent? So the 1/2 is going to be in front of everything. So add 1 to the exponent. 1/2 plus 1 is 3 over divide is the same as the reciprocal, minus, we'll see if it's minus. What do I do with the exponent? Add 1, so it's, and then leaving a space, u to the positive a half, divide, and it's the same as times 2, and negative 4 times 2 is negative 8. And that, of course, at the end you would add. Now, the last step is substitute back in. What does u equal? 2x plus 3. So if I multiply this out, the 2's, like the 1/2 can now distribute. The 2's divide, and I'm left with 1/3. And instead of u, I'm going to put in 2x plus 3 to the exponent 3 over 2. 1/2 times negative 8 is negative 4. And instead of u, I'm going to put in 2x plus 3 to the exponent 1/2, and then the candy. On the level from like 0 to 10, like 0 is, I can learn this with one question. 10 says I need like a lot more than that, right, to learn it. You're going to decide if you're going to earn learning this or not. Okay? So you got to practice with the basic chain rule, ante, and practice the U substitution's the son of a gun, right? That takes some practice. But now you have me at any time.